Okay, so we're going to look at a couple of sinusoidal application problems. These happen to be at the end of our packet. For my accelerated pre-calc students, these are the two we haven't gone over yet. We actually went over number 5 in class, but it was kind of rushed at the end of class, so I'm going to go back over that one. But I'm going to start with number 6 here. It says Tarzan is swinging back and forth on his vine. As he swings, he goes back and forth across a river bank, going alternately over land and water. Jane decides to model mathematically his motion. Yes, she's a brainiac. And starts her stopwatch. Let t be the number of seconds the stopwatch reads, and yet let y be the number of meters Tarzan is from the riverbank. Assume that y varies sinusoidally with t. All that means, whenever we say something varies sinusoidally, that basically just means, in other words, it looks like this. It looks like a sine wave or cosine wave. Okay. Jane finds, assume that y varies sinusoidally with t and that y is positive when Tarzan is over the water and negative when he's over land. Okay, so in other words, we have a scenario here where this is my time, okay? And the y value is how far he is from the edge of the riverbank, basically. When he's over the water, what was that? Yeah, y is positive when he's over the water. When it goes down here, he's over the land. So he's going back and forth over the land and water. So this is why this is sinusoidal. Jane finds that when t is 2 seconds, Tarzan is at one end of his swing where y is negative 23. So that means he's on the water side. He's in negative values, negative 23. Here he is. She finds that when t is 5 seconds, he reaches the other end of his swing, and y is 17. So he's 17 feet out over the water at t is 5, when 5 seconds have passed from the time she started her stopwatch. Let's see. Sketch the graph of this sinusoidal. So that's the first thing we're being asked to do, is sketch the graph, which is what we're doing. Okay. So this is the bottom, this is the top, and we know that sinusoids just go back and forth between those. Now if we're only going to do one cycle, that's it. I started at the bottom. When I get back to the bottom, that's it. I could keep going, but if I only want to graph one cycle of it, then I would stop there. And we've been doing a lot where we're just graphing one cycle, so I'm going to stop there. Okay, so I'd like to figure out where this is. It took him to go from this end of his swing all the way back to the other end. It took him 3 seconds. So we can also assume it takes him 3 seconds to go back the other way. Okay. Let's see, what else? I think that's about it for things that we can graph. Well, no, we can graph our midline. We'd like to know where the midline is. Midline, remember, is the average of the high and low. So if I average these two numbers, I'll get my midline. When you're averaging two numbers, if one of them is negative, you still keep it negative. Sometimes that freaks people out. They want to do something fancy with the negatives. But this is negative 23 plus 17 divided by 2. And I get negative 3. So at negative 3 is my midline. Does not look exactly symmetrical, but it's pretty close. So it goes through here and here. So I would like to know where it hits these points as well. So this one's right in between 2 and 5, so I could average 2 and 5. 2 plus 5 is 7. 7 divided by 2 is 7 halves. So 7 halves of a second, or 3.5 seconds. 8 plus 5 is 13. Divided by 2, that's 13 halves of a second, or 6.5 seconds. Okay, so that's pretty much our graph. Part B says write an equation expressing Tarzan's distance from the river bank in terms of t. So basically, write an equation of what you just graphed. So let's look at what we need to figure out. The amplitude, that becomes my A. The period I can use to tell my B, figure out my B. The phase shift is our C. And the vertical shift is our D. Okay, so the amplitude here is how far above the midline we go and how far below the midline we go. So from negative 3 to negative 23 is 20. From negative 3 to positive 17 is also 20. My amplitude is 20. Period. Okay, that's how long it takes to complete one full cycle. We started at 2. We got back down to the same place at 8. 8 minus 2 is 6. So the period is 6. Now what we use that to find is our b, our value of b, that we're going to plug into the equation. This is a sinusoidal function. Sinusoidal functions, the parent function has a period of 2 pi. So that's what we always use. We say 2 pi, the period equals 2 pi divided by b. Or if you want to change that around to use it in this case specifically, that means b equals 2 pi divided by the period. So 2 pi divided by 6 is pi over 3. Okay, so b is going to be pi over 3. The phase shift, well, that's where did we start? We started at positive 2. If we're going 2 to the right, so my phase shift is positive 2, that's our c. But remember that when we plug that in the equation, our equation says minus c. So it's actually going to have a minus in front of the 2. Vertical shift is wherever the midline is. The midline's at negative 3, so that's my d. Okay, and I'm going to plug these numbers in to this format. This is my standard form equation that I'm using, where the amplitude goes here. This is that value of b that I got from the period. This is my phase shift, and this is my vertical shift. Okay, so when I do that, I'll have my equation, and that will be y equals, let's go ahead and put it right, 20 cosine pi over 3, that's from the b that's right over here, time minus c is positive, so you'll see a minus, minus 2. That's to the right, and that's what happened. We went to the right 2 before we started. So a minus means to the right, and a plus means to the left in the equation. And then minus 3, because that's a shift down 3. Now I left some space here because there's one more thing we haven't addressed, and that is that this cosine function started out at the bottom and then went up and back down. So this is actually sort of an upside down cosine function, or a flipped one. So where do I show that in the graph? Right here, negative. So that's my equation. Now I can use this equation, I'm going to put it in my calculator, I can use it to find out specifics about this graph, to pinpoint specific locations. Okay, but it helps to remember with that the t is the time, that's my x value basically, and my y value is distance from the riverbank. So if I'm being asked how far is he from the riverbank, I'm being asked what is y. If I'm being asked what time or how long did it take or at what time did this happen, that's being asked about my x. First challenge is to put this in the calculator correctly, and that's for some people the biggest challenge. Okay, so here's the deal. I am taking the cosine of all of this. This is what this is telling me to do. So I have to tell my calculator all of that. I have to tell it cosine of, and then put it all in parentheses to say this is what I'm taking the cosine of. Now, additionally, I was looking for that word. I don't know why it was deserting me there. Additionally, this I'm not going to put in as a fraction. I'm going to put in as division, so I need to have parentheses around that too. So here's how I'm going to type this in. I'm going to go to my y equals, and I'm going to type in negative 20 cosine, and then I'm going to put open parentheses. The calculator will probably do that for me. Then I'm going to do parentheses, pi divided by 3, close parentheses, open parentheses, t minus 2, close parentheses, and now I need to close those parentheses to say all of this is what I'm taking the cosine of. Then I get a minus 3 at the end. So that's how I'm going to type that in. So parentheses are kind of your friend here. So y equals, and let's see, we have negative 20. It's too hard for me to do this angle-wise, so I will type it in and then show it to you, if you don't mind. And even if you do mind, it looks like that's probably what I'm going to do, because I can't hear you telling me you don't mind. So I'm hoping you don't. Okay, so here it is typed in. Let's see if you can see that. And now that I've shown it to you so carefully, let's hope it works. Okay, so I'm going to graph this, and I'm just going to go ahead and hit graph and see what happens. Chances are very good my window is not going to be ideal. So let's look. This window is miserable. The standard window actually would probably work much better on this one. So let's look at that. Let's do zoom 6 and see if we can get a cosine graph here. I'm not seeing one, so I don't know what's happening. I don't know if I typed something in wrong. It doesn't look like it. I'm going to grab another calculator just because I feel like I was having trouble with this one earlier. So just in case. Case is the calculator. You know what it could be? Could be that I'm not in radians. I did not check that. So let's see if that could be it. But I'm going to use this calculator just in case. Okay, right now nothing's coming up. I'm going to go ahead and see what happens if I change it to radians, because it is in degrees. There we go. So here's my graph. This is not the best viewing window still, so I'm going to change my window. And changing my window comes from what I did right here. I don't need to wait for somebody to tell me magic numbers for my window. I need to figure them out based on what I need to see here. So I want my x values to go from 0, or someplace just to the left of 0 maybe, so I can see the y-axis, to at least 8, but maybe a little bit further than that. Looking at my problems, right here it asks me about t equals 15. So I'm going to want to see at least to 15. So I'm going to do for x's, I'm going to do from maybe -2 to 20. So my window, I go to window, and for x min, I'm going to say -2, and x max, I'm going to say 20. Okay, and then I'm going to come down here and change the y min and the y max. But let's talk about what to. Well, the lowest y value I need to see is -28. The highest is 17. So I'm going to go from maybe like -25 to +25. That might be a good way to see it. You don't ever want to stop right on the edge of what you want to see, because then sometimes you can't really see it well. And this looks pretty good. Let's see if I can get it to where it's showing you a little better. There's my graph. Now, if I want to plug in an x value, which in this case is t, so in other words, if they give me a t and ask me where is he at this time, plugging in an x value is pretty easy. The best way to plug in an x value, you're going to press second and then trace. And when you do that, that's calc. That's the calc menu. The very first option is value. And it's basically saying, oh, you want to find a specific value on this graph? Yes, I do. So I'm going to press the number 1. You don't have to like hit enter and go up and down the screen. You can just press the number that's beside there. And it tells me x equals down in the corner. See how that's flashing? It's saying, go ahead and tell me what x value you want to plug in. Well, on here, I want to plug in, excuse me, t or x is 2.8. So 2.8, enter, and it'll tell me what the value of y is when x is 2.8. And on this one, I'm getting -16.38. So let's go with -16.4. Okay, so that means he's over the land, 16.4 feet in over the land. Okay, the next thing it asked me to is plug another value in of x. So I'm going to do the same exact thing. I'm going to say second trace number 1, and this time I'm supposed to plug in 6.3. And I get 1.158, so let's go with 1.2. So 1.2. And finally, we're supposed to predict the y value when t, or x, is 15. So finally, again, second trace 1 allows me to plug in a value, and I get y is negative 13. Excuse me. Okay, the next thing they asked me is, where was Tarzan? Can you see those? They're kind of hard to see. Not the darkest pen. Negative 16.4, 1.2, and negative 13. Okay, where was Tarzan when Jane started the stopwatch? Well, if she starts the stopwatch, that means her time is 0. So we're talking back here. Time is 0 is the same as saying x is 0, so that's just another plug in x. So I'm going to do second trace, plug in a value of x, and that value is 0. And I find out that Tarzan was 7 feet out over the water, or at 7. Bad marker again. Then it asks me to find the least positive value of t for which Tarzan is directly over the riverbank. Well, he's directly over the riverbank, it tells me, when y equals 0. So I'm supposed to, basically this means I'm plugging in a y value, not an x value. So here's how we do that. This is the easiest way to plug in a y value, is you're really not plugging in a y value. You go to y equals, and you create a second equation. And you fill in whatever they want you to put in for y in that second equation. Now when it's 0, there are other ways we could do it, but let's go ahead and do it this way just because this is the best way if they were to say when is y 2 or when is y negative 5. So basically if you want to plug in a y value, you go to the y equals and you graph a second equation that's just y equals that number. Now when I go back to graph, the first thing I'll see is my original graph, and then I'll see a line going through that graph that is the line y equals 0. This time I'm probably not going to see it because y equals 0 is the what? The x-axis. So I won't see it, but it's there. Let me show you what it looks like if, let's say I do y equals 5. I can't see what I'm doing, sorry. I have to tilt it basically away from myself for you to see it, and then I can't see what I'm typing. Is that y equals 5? It is. Okay, so y equals 5, here's what it looks like. Got the original graph. And there's y equals 5. But we don't want to know when y equals 5. We want to know when y equals 0. So let's go back, change this to y equals 0. And know that it's there even though we can't really see it because it's right on top of the x-axis. Okay, so now I want to find out the, what is it, the least positive value. So they're basically saying the first time to the right of the y-axis, the least positive value. Because to the left of the y-axis over here, it would be negative. Over here, it's positive. But we want to know the least time that happens. Now, it's kind of hard to tell because basically it ends up looking, it's coming up through here somewhere. We don't know if it's right here or if it's right here. It could be a little bit under 0 there. It's hard to tell where it goes through there. So I'm going to actually zoom in a little bit on just that part. I'm going to go ahead and say window. I'm going to look just at x is negative 2, and you don't have to do this, but I'm just trying to show it to you a little better. X is negative 2 to x is 4, and y is negative 5 to y is positive 5. So I'm just zooming in sort of near the origin. Okay, so can you see your curve? Yeah, you can. See how the curve comes down? It does come down to the right of the y-axis. So the least positive value, he's been out over the water and he's swinging back to come back over the land. So this is going to be the least positive value. So I want to know where my two equations meet. Remember my two equations, one is the horizontal line y equals 0, and one is the actual cosine curve. So I'm going to do second, same place I went to get value. This time I'm going to use intersect, which is 5. I'm going to press intersect. The first thing it asks me is, what's your first curve? What they're really asking you is, which equation do you want me to use? We only have 2 in here. If you only have 2 equations in there, then you can just say first curve enter and second curve enter. In other words, they're basically those options, and I'm sorry my phone's ringing, but basically those options are there for if you had a whole bunch of values entered, a whole bunch of equations entered, and you wanted to specify, oh, please use these 2 equations. But our 2 equations are just the only 2 that are in there. So first curve, I'm going to press enter. Second curve, I'm going to press enter. And then guess allows me to make sure it knows which intersection I want it to find. And I'm going to move my cursor pretty close to that spot and then press enter. And it's going to tell me what that location is. And it says that when y is 0 there, x is equal to 0.356. So let's say 0.4 seconds. And that is my answer. 0.4 seconds. Okay, and apparently somebody really wants to reach me on the phone, so I'm going to cut this short here and come back and show you the other problem.